So good afternoon.
Good afternoon.
Okay. I will be taking two sessions today. One is on water supply and second is on storm water matter.
See, nobody is sleeping.
Ha.
Make sure.
Thank you. Yes. So water supply and distribution is a very technical, whereas storm water would be an art to design. It needs a good vision, it needs good understanding of what you see in the everyday scenario outside, on the roads, around your buildings and everywhere. However, water supply is a very technical thing, and you must be residing in the many societies, bungalows. Most of the time, water supply is a very critical activity. If you don't have power, probably you can survive for a time. If you don't have AC, still you can survive, but without water and drainage, it's very difficult. If your drainage is choked, you can see what your parents have undergone or what is the scenario at home when the drainage is choked up or when there is no water. When municipalities declare that we are not going to supply the water to you for one day or with less pressure, then there is a society meeting, people gather, they discuss, so many qualified, talented people, they discuss from where we should bring the tanker, somebody starts pulling the number from tanker lobby and then they identify the charges. So this is that important. If your AC is not working, it's okay. You will probably call a person, you will go somewhere else, you will sit in a cafe for a while till the time your AC at home is getting repaired. In the winter time, even the AC is not there, still we have a good fan. Now, why I gave you the introduction for this is water supply and drainage are very critical elements of the plumbing. We'll go through it. I will try to see. This is a presentation. You will anyways get it in your emails after this complete sessions. You have to go through it. There will be competition as told by Amit sir. So you have to go technical. I will try to give you a complete scenario, a holistic scenario based on my experience that where you should focus more, what is the key areas, where you can ignore or what are the redundancies you should add in the water supply. That I will try to emphasize more. So international standard of plumbing practices are everybody's reach. You must be knowing that Government of India has made all the Indian standard codes free. You can easily download them and use them without paying anything to them. There are so many codes. When I started in 2007, the very popular was SP 35. That was a special publication IS code published by Government of India for special emphasis on plumbing. However, IPA initiated 2017. IPA also has one code in collaboration with IPPL. IPPL is an international organization for mechanical officials. So they also have a code. Although we have National Building Code of India, IPC, UPC, so many codes around us, I would say please go through that the code published by Indian Plumbing Association. It has really a grassroots level things mentioned that water, it is not only for the person who is going to practice as a contractor, but if a contractor is going to practice it, a designer should know what he is going to practice. And you should understand his type of installation, what the contractor usually does. And accordingly, your design and layouts should be such that it should complement the contractor because actual residents are going to use it. So there are several codes, there are formats, they are available for purchase, I think. I don't remember, Rupeji, do we give some codes free for these people at the end?
I think code book will be given in the part of those. Code books will be given by coming Saturday.
Okay, so
It will be distributed to everyone.
okay, so one I think you will get, but there are several. So basics of water supply. So although it is mentioned, I would give you a brief. So there is a source. Source can be river, pond, which is a natural. Okay. From there we have to pick the water. So technically it is called as lifting station. So have you undergone to the terminology section? Terminology?
Yes.
So plumbing terminology is very
I've
important.
done that today in the morning.
Okay, so plumbing terminology is a very important thing. That is the only thing which will give you identity that you guys know plumbing. Because every industry has their language. Computer has C, C sharp, Python, many things. So this industry is also, firefighting also have their own language terminologies which can be communicated. If you are sitting in front of a client, if you talk technically, they will understand. If you have a very nice English, they might not understand if you don't use terminology. So the picking up, that water picking up point is called as jack wells. The water is lifted. It is taken through the rising mains. Rising mains are the pipes which has diameters more than a feet, and they are very heavy. They can take a very heavy pressure because from river you are picking up the water up to the storage tank where you are going to treat it. Okay. So possible sources, as I said, surface, lake water, pond, underground sources. We have open well, bore tubes, harvested rainwater, recycled, and there are many things. So each sources has its advantage and disadvantage. Like river has good water. If you go to the borewells or wells, it is rich in minerals. So maybe you need to put a demineralization plant to make it drinkable. Rainwater is a very good source, but it does not have any minerals. If you start drinking rainwater, your stomach will get upset because our stomach is habituated to drink the water with minerals. So many times when we design across and there is now emphasis by the MOEF that there has to be the rainwater harvesting tanks, and that cannot directly be used for the drinking purpose. At least mix that water with normal municipal water which has enough minerals so that nobody will have problem. So everything has pros and cons. Why I am trying to tell you all these things? Because there is a behind this every word there is a big thought process, big descriptions are there. You should get into that. Okay, your future, those who are young, those who are experienced, they can guide you. They can also tell you. But behind every word there is a big meaning, big description, big thought process is there. Then water treatment. There are several water treatments. We always hear that river is the best water to drink. Nowadays it's not true. But why river water is good to drink in earlier days? Because it's a natural treatment. Why it is a natural treatment? There are bacteria, there are natural filters, it goes to several stones. Okay. There is a vegetation inside the river. That's why the water gets treated automatically. There are biologies, there are fishes, there are small bacteria, good bacteria. So that's why rivers are called as natural treatment processors. However, you must be knowing that if you see any time the city level treatment plants, it has silting chambers, it has clariflocculators, many things. But what we have at home is extremely different. What we have is, we have purifiers. They purify the water and it has a very huge amount of reject water also. So from where you are picking the water, it decides the treatment process. If you are picking the water from Kalyan Dombivli region, you have to treat it very vigorously. The reason, there are so many chemical industries are there. There are so many jeans manufacturing factories are there which washes the jeans heavily. So they use heavy soap detergents and you need to have a very vigorous. Maybe if you go to the interiors of the Maharashtra, let us, I would say Jalgaon or that side, Vidarbha area, if you are taking the water from over there, you may not require the so vigorous treatments because people are, the industries are not very aggressive over there, they are not polluting the river. So that's why it is said depends on the quality of water and purpose for which it is being, the treatment process can be decided. Again, if you are using it only for flushing like we do it in our building systems, then you don't need a very RO kind of treatment. Reverse osmosis is not required. Then storage tanks. There are several storage tanks. We have ESR, GSR. Can anybody tell me what is GSR? Please. Easy.
Ground storage reservoir.
Very good. So, because most of the people are from plumbing background, it is in the infrastructure. It falls usually in the infrastructure. Civil engineers knows it very nicely. So GSR is ground service reservoir. ESR is elevated service reservoirs. So ESRs we see in the vicinities which used to supply the water. Nowadays there are no more ESRs. But earlier is if you go to the interiors of the states, then you can see so many ESR. It has a natural pressure building. Naturally pressure is built, so distribution is very easy. They don't need any pumping for the distribution. So storage tank has different. So building we have normal storages. Then there are different type of material. Indians are very fond of RCC. We like or brickwork tanks. We like to live in a home which is of RCC or brickwork and all. We don't want a home with wooden partitions. We don't want a home with a glass partitions. Offices are fine, but we believe and our zones, fortunately, seismic zones, I mean to say, are not that critical. So where the seismic zones are very dominant, like Japan, they can have a very lighter material which behaves properly in times of seismic activity. However, so storage material, we get digressed, but anyways, storage material, steel tanks are there, RCC tanks are there, brickwork tanks are there, nowadays panel tanks are there. So fiber panels of 2 meter by 2 meter, 1 meter by 1 meter, even 1 feet by 1 feet, along with whatever type of access, I mean the holes for the pipe you need, they also provide that. Water leak tight joints and everything. So different materials are there. Type of tanks, circular is there, rectangular is there, top axis manhole, side axis manhole, they are also there. So these are the mostly things we covered. Then there are compartmentation. So nowadays buildings are tall, we have huge tanks of lakhs of liter, maintenance is difficult. So if we have the proper compartmentation, then we can probably shut one compartment and maintain another compartment. Also storage is, redundancy is always better. The water tank shall not have the direct connection to sewers. This is a very common sense things which are need to be taken into account while designing or thinking about the locations. Even if you see the sewage treatment plants and water treatment plants should have at least 300 to 500 minimum gap. It is suggested by the municipalities also and the MOF committees also. You cannot have a single wall. On one side you are treating sewage and on another side you are storing the water. Even if you are just having a partition, that is also not allowed between those two. So, low level tanks shall not be located below the ground to avoid the contamination. So storage location of the tank. So GSR we talked about. It is natural that if your tank is so much deeper inside, there is a chances due to the capillarities, the ill water may get contaminated with the tank water. On inspection, that third point which is we take, inspection covers. So if the tank top is like this, you cannot have the tank cover at this if there is a movement, specifically vehicle movement or human or any kind of movement. The reason is there is a chance, although we have double seal tank covers, we do not have the single seal or we do not have the casual tank covers. Still it is recommended that there has to be some upliftment only for that cover. That's why you must have seen while driving and you must have cursed the consultant that or contractor why he has elevated that particular part which is obstructing every time with my car or bike. But this is for that, so that even if there is a water logging or even if there is a water accumulation for XYZ reason, the water should not go directly inside the tank. So yes, this point, the plant room. I'm just trying to avoid the points and trying to focus on the points which are more important for you to focus. So tank, we must have seen that plant room and tanks are usually adjacent, and it is it is a good engineering practice that the plant room should have at least a 1 feet below. Plant room bottom should be below 1 feet at least from the tank bottom. The reason is when we have the positive suction to the pumps, it should be, the geometry should be suitable to it. Otherwise, what will happen if our tank and pump room are at same level, we may need to suck the water. So suction is allowed. There is a misconception that suction is not allowed. That's why we can. There is a suction is allowed. Suction is again a phenomena by nature. Like gravitational pressure is a phenomena by nature. So suction is a phenomena by nature. You cannot have suction more than 7 meters for any pump in the world. Which are pump outside, submersible I am not talking. So suction cannot be more than 7 meters. But then pump has to work more. It needs more energy, more power, pump piping. So that's why nowadays it is famous. If you go to any consultant, any building, always there is a positive suction in the tanks. That's why it is advised that the plant room should have 1 feet below. If your pumps are heavy, your buildings are very tall, the 1 feet can go to 2 feet as well. But minimum it is better. Provision for the overflow is always important thing. Now I will tell you the simple phenomena of overflow. How to decide the overflow? What is the size of a टैप? जो हम लोग पाइप लेके आते हैं और एक बेसिन के टैप को लगाते हैं, what is the size of that minimum? Can anybody tell?
So bigger than inlet diaphragm.
I am just asking you. There is a tap, basin tap,
50 cm.
right? But what is the minimum size for drain?
40
40 mm. Minimum 32 earlier used to be, but 40 mm. That is the ratio. That is the ratio. You should always remember for designing any kind of overflow. We always miss this thing while designing. We think that 100 mm inlet is there. We have given a 100 mm overflow. This will do. This will never work because inlet always work under pressure. What is the minimum pressure we design? Maybe 1 bar, 1.2 bar. So there is a water is coming with pressure. Water is not coming under like normal. It is not with a zero pressure at outlet. So that's why our inlets are smaller size and outlets are of bigger size. Same you should do. So whenever you are designing the overflow of a tank, it should be like that. That if you have a 100 dia inlet, at least 150 dia overflow, or at least 100 mm overflow should be given. This is thumb rule. You can of course design. There is always a design concept available. So water supply system, water mains, water service, meter, valve. Simple. Main is municipal line which is there at the outlet. Now I will try to take little fast because I think I have created a picture, a thought that what is the water supply. If you feel that you need to understand more deeper, please raise your hand. So mains are there, then services are there, then ferrule connection, water meters are there, then there are valve accessories. The red is hot water line, blue is normal cold water line. Description and definitions you should know being a plumbing engineer. Then this is the distribution type, very simple. We have a storage tank, we have a lifting arrangement of the pumps. The water goes to the overhead tanks. Usually it is mounted on the staircase so that the top floor should get pressure. If top floor is not get pressure, you are designing it for a very high-end residence, then you can have a hydropneumatic system. Okay, and then there is a gravity system. This is the most ideal condition. If anybody is coming with you that I have a best pump technology, I have this, that, too good. Our country do not have 24/7 power supply guarantee. So, no matter what best technology you have for distribution, please try to follow this. And this is given in the National Building Code, so no harm in following of this. These are some terminologies. Residual head. What is the residual head? The head, when you start a tap and the pressure which you get is termed as residual head. Let us say, very quickly, I will just try to move fast. You have a 100-meter tall building and your pump head is 100 meter. You will never get the water at outlet. Why? It will come up to the top. It will come up like that. It will come up to the top, but it will never come out of the tap. Reason? Your head calculation is wrong. So residual head is very important. What is the usual residual head? It is, we take it 10 meters of water column or 20 meters of water column, not more than that. Because beyond 2 bars, it is uncomfort to the humans. So residual head is there, residual pressure, saddle, service. So these are technical terminologies, you can just go through it. Water requirements of the building. So where it starts? Population. How you can identify the water requirement? There are 2 criteria. One, what is the amount of water required by one person and how many persons are going to reside in that building. So if, what is the amount of water agreed by government? Anybody? 135. Is it complete? Is it full? That is for
1 day.
1 day, but domestic use. Not domestic, domestic and flushing. So domestic is how much?
90.
Right. That is how. Now you guys are there. You understand that what is a split, what is the per person requirement, domestic flushing. How you will calculate the population is this. Earlier I think it was just 5 persons or 4 persons per apartment, but now it is, because residents increases, 4 person, 5 person for 2 BHK and 3 likewise. So these basically forms your basis of calculation, which is very important. As I mentioned in the very first statement, water supply is a precise and technical business. Then different type of building has different demands. Like as you said, 90 and 45. So hospitals, factories, restaurants, food courts, there are different demands. Here I will just spend 1 more minute on this slide. Restaurant calculations are little bit different. Residential are little bit different. Residential you consider 90 liters per person per day. Whereas restaurant you need to consider about visitors. How many meals per day probably. So that would be your calculation basis. So different type of occupancies. Now these are the maximum flow. Now there is a split of that 90 also again and 45 also again. We will not get into it, but as we said, that separate fixtures requirement. Water closets 6 liter per flush, urinals 3.8, lavatories 1. So different flush per minute or per use. Now these are the given in NBC, but maximum. So any fixture which is discharging more than this is unqualified. Then you can go for Indian Building Councils, they have their own lesser flow rates and all. Water supply fixture rate. This is very important. This is these are the minimum sizes. So what is the fixture unit for bathtub is 4, big tap is 1, There are urinal with sensor operated 2, WC 6, minimum pipe sizes are there. So this part of PPT you can read. I will just give you a simplistic global picture. Now you know how to calculate the water demand. Number of persons into per person demand. Multiplication is your storage requirement and water demand of a day. How you will calculate the pipe size? Pipe size can be calculated by Hazen-Williams formula. So I am going to backtrack it. What is required by Hazen-Williams formula? So we will start it from the initial. Like how many fixtures I need to cater in a building? How many WC? How many health faucets? How many bib taps? How many showers? Okay. I will tell you a glitch in that also, but later on. So I identify number of operating fixture at one point of time. If I have a shower, health faucet, and bib tap, what is the maximum fixture unit? Shower has maximum fixture units. And nowadays toilets are closed incubation. So only one fixture will work. That is a thought process. Somebody can come and say, "नहीं, मैं तो shaving भी करूँगा, गर्म पानी भी लगाऊँ." That's all. But we don't design for a specific condition. We design for general condition. So we calculate critical number of fixtures multiplied by fixture units given here. Okay. So you got total fixture units. You go to the table 3 of NBC part 9. What is the table 3 says? Probable simultaneous demand. In that there is a column comparative, that fixture units versus flow in LPM. So simultaneous. Why simultaneous? Let us say there is a building which has 400 WC. Will they get operated at one point of time? Never. That is why probable simultaneous demand. So fixture unit fixture we identified. We multiplied by number of fixtures operating at a time. We go to the table 3. We found out probable simultaneous demand. We got LPM, liters per minute. Then we put it in Hazen-Williams formula, and what we get? Pipe size. Okay. This is a simple flow, which is given in here in more elaborative manner, that what type of fixtures you are having in a building. These are the graph. These are below the table 3. If your fixture unit increases, I think beyond certain numbers, then you can use these graphs. This is the probable simultaneous demand table which I told you. Okay. So fixture units, probable simultaneous demand, it goes to the Hazen-Williams formula and you get the pipe size. Hydropneumatic system. What is the difference? I earlier mentioned that we should go for the gravity system, not for the hydropneumatic system, but mostly commercial building goes for hydropneumatic. Second, the good example in Mumbai, funnel zones. So wherever funnel zone is there, builder want to construct maximum sellable apartments. So he is not in interest to provide the overhead tanks. In such cases, hydropneumatic system proves its worthiness. What it has? Storage tank, a pump calculated based on fixture units operating at one time on probable simultaneous demand, and then it supplies the water to everyone. Now, however, while designing that, out of this course, you should know that fire tanks are always required at overhead. That cannot be diluted. Overhead tank distribution. So, usually as per NBC, we design the underground tank for 1 day and overhead tank for half day. How it operates, it is given in simple. Again, I will tell you the story. Means generic thing about it. Technical will follow in the picture. There is a overhead tank which has a high level sensor and low level sensor, which are connected to a PLC controller. Okay, the PLC controller is connected to the pump panel. Simple, I will again explain. Overhead tank has high level sensor, low level sensor, which is connected to a programmable logic circuit controller. Okay, so that PLC panel is again connected to the pump panel at ground level. There is another way also which I will explain, but this is the most common way. So once you have a low level water, your pump should start. Once you have the water at top level, pump should stop. So this is a very simple. Nowadays the buildings are very tall. Okay, the front building is probably 250-meter tall. What most of the what they do in such cases? So there is a pressure sensor at ground only, because in the earlier case which I told you, need to have a cable running from top to bottom. Now you don't need to run the cable, because again it's a risk. Cable may get broken, it has a life, etc. etc. So you install a pressure sensor equipment at bottom. You know what is your delivery residual pressure. Accordingly, you know what is the pressure at bottom. If the tank fills, what you have there? A ball valve, which what it called? Solenoid, not that. The
Float valve?
Float valve, right? Mechanical valve.
Mechanical.
So that can be there. The motorized valve also can be there. But if we go for the analog system, then float valve is there. Float valve will shut if the water is filled. What will happen if it shuts? The pressure in the piping will start building, because your pump is there. So if the pressure is beyond certain limit, it will stop. There is again a PLC which will sense the pressure from pressure switch. It will tell the pump panel that Mr. Pump panel, please switch on. So there is another problem. So this is basically about the distribution irrespective of gravity. Gravity system is again very simplistic. You should know the gravity systems in detail, because hydropneumatic is exactly opposite to it. It is top down, whereas the booster are bottoms up. So these are technical things. Maximum permissible velocity 2.4 meter per second. Then there can be debate why 2.4, why it cannot be 5, why cannot be 1. But somewhere it has been standardized by the code, so we are using it. Hydropneumatic, as I said. So here you have a loop at top. Here you have a loop at bottom. Water supply distribution system, hot and cold. So as we have cold water system, tank is there, we have a distribution loop, and then it goes to the various downtakes. Similarly, hot water, what we will have? A tank outlet connecting to the solar panels, which is storing the water in the hot water storage tank. It is a SS tank with some thermal insulation. Then it is connected to the loop, and then there are gravity things. You should be aware of what controls, means what valves are required on each system. So hot water flow, how you can calculate? Again the pipe sizing for the hot water, the flows are given. The kitchen sink will have this, wash basin will have this, shower will have this. The minimum permissible length for hot water. This is again an important criteria, because the heat losses. So if this is the lengths are within limit, then the heat is not lost much. Portable and not portable system. Color field and sizing and lettering. So these are the basically tags in our world, what we call it. So how the tags should be there? They have given the sizes and the text heights and everything. Unacceptable connection. No installation of potable water piping or parts shall be made such manner that it will possible use for the unclean, polluted, contaminated. So basically, even if whenever you are designing the infrastructure line, building में ऐसा होता नहीं है, but when we design the infrastructure line which are running below the soil, water supply line and sewage line usually have 500 and 500 distance. So even if they don't run beside to each other, so these kind of criteria are there. So connections, it is an incorrect practice. The code may not say that it is bound, but while designing as a good engineering practice, it is mentioned. Water hammer, again an important aspect. You must have seen in your childhood that you are closing the tap of basin, then it is giving a shivering or shocks. So water hammer arrestor, is equipment. This type of equipment is available with many wall manufacturers, which absorbs that shock. Nowadays, water turn walls, taps are there. And what is our tendency? We want to watch the reel. So, we want to shut the wall very quickly. And we shut the wall, it generates a shock wave, which damages your fittings. But we are not care about it. So, there is a product. So, we have a water hammer arrester, which arrests, which have a cushion tank in it. So, it arrests that shock wave for a momentary purpose. So water is a scarce natural resource. It is no longer affordable. Trust me, the coming time, I was designing a very large parcel, and before 15 years back, and somebody came to the developer and he said, "I will buy your complete sewage after 10 years, and I am ready to pay today onwards." So people are thinking in that way that today I will buy the sewage, I will treat it, and I will sell the water. Even if you go to the most part of the world, you will find treated water for drinking. Maybe Singapore, somebody has traveled, it is mentioned on the water. And RO system, treatment system, any which ways we are throwing our sewage. Somebody is treating it, maybe nature, through the rivers, and again we are drinking it. Only thing, it is going to happen in a short cycle. So be careful about the water treatments and utilization. I think I have explained you much more, not exactly from the slides, but I hope you got the intent how the water supply system should be. I am happy if you ask questions. If you feel, you can write it, send me later on to the IPA email ID, and I can answer.
सर 60-65 स्टोरी अगर बिल्डिंग है तो वहाँ जो हाइड्रोमेटिक सिस्टम हम लोग डिज़ाइन करेंगे तो एक पंप सेट में 60 फ्लोर प्ले हो जाएगा या हाउ इट इज
कैसे करेंगे? सो nowadays this question will be arises to everyone. मैं आपको एक सिंपल लॉजिक बताता हूँ, ठीक है? What is the maximum pressure bearing capacity of a pipe at 27 degree centigrade? चलो, let us consider it as a 10 bar.
10 to 15
ठीक है? तो what is the 10 bar मतलब 100 meters of water height.
यस
तो 100 मीटर का बिल्डिंग आप बना सकते हैं. 100 मीटर के बिल्डिंग के लिए या 100 मीटर के हाइट के लिए आपका रिस्ट्रिक्शन आ गया.
रिस्ट्रिक्शन
अब आपका 65 स्टोरीड है तो मतलब 200 मीटर के आसपास है. रिस्ट्रिक्शन कितना है?
100
तो आपको कितना करना पड़ेगा?
2. थैंक यू.
Any further questions?
Water arrest मतलब suppose we are having a 50-story building, तो actual कहाँ पे लगेगा?
Water hammer arrest location. So a shock wave is generated. Okay, it will propagate in the way the pipeline is installed. ठीक है? Where it will generate at the tap level. So जो pipe we take it from the shaft inside the toilet, a horizontal pipe from where we take the branch connections. The end of that pipe, it is advisable to have the that equipment, or where it is connecting to the main shaft. There you can connect the water hammer arrester. So 2 locations. If you want to be really more precise, you are making a home for someone very wealthy person or a very influential and important person, then you can have it connected at every time. But shock waves are dominant, but इतना भी dominant नहीं है कि it will impact even a individual fitting. Shock waves are dominant if your pressure are very high. If you have a rain shower kind of thing, then you should have a shock wave arrester over there also.
Is there any model thing is
There is a book which I can share, which has all the calculations, set of calculations given how to calculate the shock wave. But there is no code I have came across as such.
It's not a codal requirement, it is a design requirement. Any questions?
Yes, we UGT is unavoidable. Yes. So that is what is gravity. Hydronomic, you can avoid the overhead tank, not underground tank.
Is there any current development like till date we are using main line water supply line is going to fire tank, there it is going to domestic. Is there any recent development where we have to fill the water in domestic, like anything is there happening or
It will never.
it will never?
We are designing globally. Sir is also designing globally. It is global standard.
It's a global
That
standard.
It comes to fire and then it circulates to domestic.
There is a basic reason. Water if stays stagnant तो उसमें फंगस और ये सब ये होता है कंटेमिनेशन होता है तो उसको अवॉइड करने के लिए वो
I think his perception was different.
And that reason I know, I got in one of the building, I got this document to water should be.
So they must be not. I'll tell you what happened. Some societies, some developers, even in my project, I don't take the name, but then later on they got number and then directly take a connection to the domestic tank. And some building, and there was fire in the building. That time there was no water in the fire tank because it was been bypassed. The reason we don't know.
There is a reason actually we are facing this kind of issues because what happens if you have a common fire system for multiple towers and you have a separate domestic tank for each building. In that case, जो incoming line है आप कहाँ पर connect करोगे?
No, but then
So,
from
yes.
the fire tank you can take multiple overflows, no?
Yeah. So if your tank is
But
far, are
that-
you saying your
that
tank is
water-
far? Are you saying that your domestic tank and fire tanks are far?
In same line,
Okay.
adjacent to the fire tank only. But what we are taking building wise connection.
So, I mean, what he's trying to say, if fire tank is say 4 lakh liter, and there are say 4 wings, A, B, C, D. So from that fire tank, we have to take 4 different overflows.
In that case, जो सोसाइटी का क्या कहना है कि जो मीटर लगा है वो तो फायर टैंक के पहले लगा है म्युनिसिपल मीटर, तो वो कैसे कंज्यूम, किसने कितना वाटर
So उसके लिए एक अच्छा solution मैं आपको बता देता हूँ. Usually you should have one underground tank for fire and domestic, but जो आपके wing wise overhead tank है उसके लिए आप separate pump लगाएंगे, and then you can monitor.
pumping are separate only, but this is the case for incoming line.
नहीं, इनकमिंग तो कैंप चार्जेस आएंगे ना, आप जो पानी रेसिडेंट्स के अलावा यूज
उसी
कर रहे
में
हैं.
सोसाइटी को इश्यूज है. These issues are raised by the FMD only because they are facing this.
You should divide it by 4, that's only the solution. It should be divided by 4 or 5, whatever, that's only the
Society
solution.
problem.
There is no other solution, right? There is no other
It's
solution.
not
You
engineering
can't-
issues.
AC trains, is it, can we connect to rainwater pipes?
We can, but again that water, because it's a non-rainy season, if the systems are off, then it's a problem. So AC drain can be used for that.
And this what is water supply piping, like gravity or whatever, which is GI is schedule 48, which is the best when I with what of cost and technical point of view.
Which is best material?
GI or
If you ask me, honestly, I would say PEX is the best material, but it's expensive, and our country cannot valid economical people. So CPVC is as on date proving its best position. So CPVC is and wide available.
Ratings will change based on the pressure ratings also, depend on the building height, whether it's a schedule 40, 80 or 120, whatever.
But for main lines, municipal is not allowing this CPVC pipe, right?
Yeah, it is distribution, building distribution. Your header, underground to overhead tank lifting header should also be GI.
Okay.
Because it has shock loads, it has heavy pressures and many things. Then it goes into detailing. If we generalize, CPVC is proving at least so far good. And if it is hot water, then sir is there, he can take.
Next presentation he will explain.
Yeah.
In one of my project, consultant asking for drinking water not to use the CPVC pipe for specific reason.
There is a notification given by WHO
Yeah.
2 years back. But जैसे हम लोग ने 50 साल GI में पानी पिया with rusted water and still nothing happened. So again,
I
what
good
is
for health.
what is alternative we have? We don't have anything alternative. to CPVC if we follow that circular.
I think we can have a small break for tea, then we'll back after 15 minutes.
Thank you. Thank you.
Thank you, Amit. Thank you, Amit, so much.